Yeah. So we are going to discuss on the armature flux here and how we are going to get the armature flux, etc. See what actually we are having. So in the previous video I told you how we are going to generate the EMF, and when we are going to connect a load, how I mean the current used to flow. Due to that current flowing in the armature, what is going to be happen? There will be some flux which is going to be produced. Okay, and that flux is nothing but what? Armature flux. And to know the direction of that armature flux, right, we are going to use another rule called right hand thumb rule. Okay, so right hand thumb rule, what actually it was saying. So right hand thumb rule, in the sense, the thumb represents the direction of the current, and the remaining four fingers represents the curled finger represents the direction of the flux. So that means this is my right hand here, and this is what the thumb. So the thumb represents the direction of the current, and the four fingers, right, the curled fingers here, not like this, the curved fingers represents what? The direction of the flux. So if you clearly observe one thing, we have already derived one conclusion, like, so before the flux axis, right, I mean the side before the flux axis, brush axis, the current is always cross, and after the flux axis, brush axis, the current is always dot. Otherwise the conductors, right, the conductors which are lying under the north pole always have the cross in it, and the conductors which are lying under the south pole always have the dot in it. Okay, so that means we know cross represents the current is entering, and the dot represents the current is leaving. Now we have to focus on how the armature flux is going to be flowing, and in which direction it is flowing. So we came to know that the main reason of producing the armature flux is nothing but is what? As the current which is flowing in the armature, so due to that current only the flux is going to be induced, and that flux is going to be flow in a proper direction, and the direction can be found by using right hand thumb rule. See, I told you I'm going to use the right hand thumb rule. Please focus here. So the current is entering. So the current is entering in the sense this thumb finger is like this. Okay, this thumb finger is like this, and if you clearly observe one thing, the four fingers, the curled four fingers are moving like this. See, the thumb finger is moving like this, and the curled four fingers are like this, right? So that means I am going to get a pattern like this. How I am going to get a pattern? So I am going to get a flux pattern like this. So this is the flux pattern. I am going to get a flux pattern like this. Okay, and the direction of the flux, so as it is, as it is moving like this, right, the direction of the flux is getting downwards here. So that's the reason I am going to place the condition like downward direction. I hope my red color is clearly visible. Okay, now if you apply the same right hand thumb rule in the under the south pole conductors, so then the current is leaving like this. See, coming towards us, and the current is, my thumb finger is showing towards me. Okay, so the thumb finger is showing towards me, so my direction of curled fingers will show us the flux direction. So it is moving like this. So this is what the curl. So thereby I am going to have some kind of field like this. I'm showing you like this. Please wait for a while. I'm going to have some field will be like this. Am I right? And the direction of the flux according to the thumb rule is going to be again like this. So I would like to show with the blue ink only itself. Okay, na? So my direction is like this. So my direction of flux is like this. So ultimately my flux direction is downwards, and that flux is nothing but what? Armature flux. Ultimately, my flux direction is downwards, and that flux is nothing but what? Armature flux. So what actually happened, my dear students, if you clearly observe one thing, my main field flux is moving like this. Okay, the armature flux is moving like this. So finally, there is a cross magnetization here. The reason is what? It is moving perpendicular. It is crossing the main field flux. So that's why the flux direction of the main field is going to be changing. Right? How it is going to be changing, etc., etc., we will be discussing now. Okay. So once again, I am repeating you, due to the current produced in the armature, a flux is going to be induced, and the direction of the flux is going to be found by the right hand thumb rule. So by using the right hand thumb rule only, I have provided these directions, and finally we came to know that the flux direction of the armature flux is pointing downwards, which is perpendicular to the main field flux phi f. Right? So we are having different terminologies here. See, this is nothing but what? D axis. Right? So the pole to pole axis is D axis, and which is perpendicular to the D axis is nothing but what? Q axis. Okay, so that is quadrature axis, and this is direct axis. And moreover, this quadrature axis is also known as geometrical neutral axis, G and A. Okay, and here it is the brush axis, here it is magnetic neutral axis. If you clearly observe one thing in the previous video, in the magnetic neutral axis, the EMF is going to be induced equal to 0. So the axis in which the EMF is going to be equal to 0 is nothing but what? Magnetic neutral axis, M and A. Okay, now what is the resultant flux direction, sir? What is the resultant flux direction? See, we actually have the main field flux is moving in this manner, phi f, and we came to know that the armature flux is moving in this manner. What it is? Phi a. So finally, we are going to have the resultant flux will be like phi r. So that means there is a distortion in the main field flux. Actually, it should flow in this manner, but it is flowing like this. Okay. Now we'll focus on the third case, where how the resultant flux is going to be represented here. Okay.